I have had several people ask me if I will help you guys understand what's the best way to help students with a multiplication chart. And we've looked at this at CNPs, we looked at it at Back to School, and I was asked for a video to help explain how to help kids with a multiplication chart by finding patterns in the chart instead of expecting kids to count on. So if I needed to know my sixes, I would say 6, and then I would do 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That takes kids forever, and they miscount, and they can't seem to complete a multiplication chart because that's frustrating and tedious, and the cognitive load that it takes wears them out, and they get frustrated before they get to the end. So let's talk about a better plan. What we really want kids to do is recognize the patterns in our number system that they can find in a multiplication chart. So this will help every student, from your special education students who receive those services to every kid benefits from understanding the patterns in our numbers. And so instead of giving them flashcards or making them sit and try to memorize, let's help them find the patterns and be flexible in understanding ways to figure out the multiplication facts that they don't know. So I want to show you how to get kids to that point. So we're looking at a 12 by 12 multiplication chart. That would be appropriate for 4th grade and up. It would not be appropriate for 3rd grade. 3rd grade would use a 10 by 10 multiplication chart. And notice my chart does not have zeros. I want a chart that has 1 through 10 if you're 3rd grade, 1 through 12 if you're 4th and up. And when I start with kids, I want them to begin by only completing the 1s, 2s, 5s, and 10s. So my step 1, complete rows 1, 2, 5, and 10 only. And then you're going to direct teach the pattern for finding the 3s. Now most of your kids are going to say, I already know my 3s, I can skip count by 3s. Perfect, because then you're going to be able to see that this pattern you're finding is correct because you already know your 3s, and you can check by skip counting your 3s. So together we are going to do the 3s. And what I want kids to see is the pattern that is happening. So together, complete the 3s row. And the way you're going to do that is by helping kids see that the 1s row plus the 2s row equals the 3s row. Why does that work? Because 2 sets of anything plus 1 more set of that same thing is 3 sets of whatever that is. So 2 plus 1 is 3. 4 plus 2 is 6. 6 plus 3 is 9. 8 plus 4 is 12. 10 plus 5 is 15. That continues all the way through to 24 plus 12 is 36. So now I've completed my 3s row. We can prove it together by skip counting by 3 to make sure that they agree that that works. And you need to help them understand the why. This is just being flexible with decomposing your numbers. 3 is the same as 2 plus 1. So 3 sets of something is the same as 2 sets of something plus 1 set of something. So if I'm talking about equal groups, 2 equal groups of something plus 1 more equal group of that same size is 3 equal groups of that, which is all multiplication is. So once I've done this, I would now have my 1s, my 2s, my 3s, my 5s, and my 10s done. And then I would ask kids, could we use some other pattern to complete our 4s? What option could I use to complete my 4s? And I would ask them, what 2 numbers could I add together to equal 4? Well, I can either add my 3s and my 1s, or I can double my 2s. Let's check and see if that works. I want them to use 2 fingers to go across. 3 plus 1 is 4. 6 plus 2 is 8. 9 plus 3 is 12. 4 plus 12 is 16. 15 plus 5 is 20. It works all the way down here to 36 plus 12 more is 48. Because 3 sets of something plus 1 more set of something is 4 sets of it. It also works to double your 2's. 2 doubled is 4. 4 doubled is 8. 6 doubled is 12. All the way down, 24 doubled is 48. So now once I've done that, so then we're going to next ask kids what 2 rows could we add together to get our 4's. So once we've done that, we have all the way through our 5's plus our 10's completed. So now the next section is our 6's. And here's the thing. This section right here is where kids struggle the most. So now I'm not having them guess what is 6 times 9. Is it 54? Is it 56? Is it 58? I don't know. I'm just going to guess. And then when they try to count on, it messes up everything after it. Instead, I want to ask them, what 2 rows could we add together to get our 6's? So what are 2 numbers we could add together to equal 6? Well, I could choose my 5's plus 1. I know those. I could do 4 plus 2. I know those. Or I could double my 3's. So let's see if it works. Here's my 5's and 1's. So we're going to follow down. 5 plus 1 more is 6. 10 plus 2 is 12. 15 plus 3 is 18. 20 plus 4 is 24. Let's see if it works with 2 plus 4. Here's my 2's. Here's my 4's. 10 plus 20 is 30. 12 plus 24 is 36. 14 plus 28 is 42. Let's see if I double my 3's. 24 doubled is 48. I could keep going. 30 doubled is 60. 36 doubled is 72. We're just decomposing numbers. So then we're going to, so that was step 4. Same for 6's. Then we're going to do the 7's, 8's, 9's. So you take a minute and prove that this works with your 7's. What are 2 things you could add together to equal 7? 6 and 1, 5 and 2, or 3 and 4. So check those rows. Is the 6's row plus the 1's row equal to the 7's row? Is the 5's row plus the 2's row equal to the 7's row? Is the 4 row plus the 3 row equal to the 7's row? Yes, because those are ways that you can decompose 7. So do the same thing for the 8's, and then let's talk about the 9's. We teach kids tricks for the 9's, and they have no idea why that trick works. So instead, let's stop teaching tricks and start teaching them the math behind it. We know there's lots of things we could add together to get 9. 8 and 1, 7 and 2, 6 and 3, 5 and 4. But here's one other even easier way for the 9's. The 10's row minus the 1's row. And you're thinking, oh, they can't do that. Trust me, they can. I've done it with all levels of students. I've done this, and it works. So why does that work? Because 10 sets of anything minus 1 set of that same thing is 9 sets. So let's look. 10 minus 1 is 9. 20 minus 2 is 18. 30 minus 3 is 27. 40 minus 4 is 36. These kids can do this. 50 minus 5 is 45. 60 minus 6 is 54. 70 minus 7 is 63. I can do this for the entire chart. I'm just looking for ways to decompose numbers. I'm looking for patterns. Once my students have learned this, they can fill out a multiplication chart correctly in no time at all. And then think of all the ways that they can use that chart. Obviously for multiplication. They can also use it for division. They can also use it for finding equivalent fractions and simplifying fractions. Let's look at that for a second. This is just a relationship. 1/2 is equal to 2/4, 3/6, 4/8, 5/10, 6/12, etc. 1/3 is equal to 2/6, 3/9, 4/12, 5/15, etc. It doesn't have to be a unit fraction like 1/2. How about 2/5? It's equal to 4/10, or 6/15, or 8/20, etc. How can I use it to simplify fractions? Well, let's say I had the fraction 12/18, and I need to know if I can simplify it. If I can find 12 and 18 in the same column, then I know I can start at 12/18 and go all the way back. It's equal to 2/3. Prove it if you need to. They're both divisible by 6. If I divide both by 6, I get 12 divided by 6 is 2. 18 divided by 6 is 3. If I need to simplify 21/35, if I find them both in the same column, I go all the way back because I'm dividing both by 7. 3/5. 21 divided by 7 is 3. 35 divided by 7 is 5. So I can teach my kids so many great patterns in this, and it helps support their understanding of proportionality. How are numbers related? That's all this whole chart is about, and we make it about memorization. Kids don't need to memorize. They need to understand how to compose and decompose numbers and how to find patterns in our numbers. So that is how you teach, filling out the multiplication chart by finding patterns instead of hoping they memorize it or expecting them to count on every time. If you need me to come demonstrate this or you have questions, please let me know.